Alright, here we're going to take a look at some story problems and talk about inequalities to solve them. So, Elvira, the cafeteria manager, has to be careful with her spending and manages the cafeteria so that they can serve the best food at the lowest cost. To do this, Elvira keeps good records and analyzes all of her budgets. Elvira's cafeteria has those cute little cartons of milk that are typical of school lunch. The milk supplier charges 35 cents per carton of milk, in addition to a delivery charge of $75. What is the maximum number of milk cartons that Elvira can buy if she has budgeted $500 for milk? So, the idea here is trying to figure out what piece of information we have and how they're connected. Okay, so we know, first of all, we have $500 budgeted. Okay, so the question is, when you make a budget, can you go over it or not? Okay. So we should understand here that the maximum amount she can have is $500. So we don't want whatever she's going to be spent to be bigger than $500. We want it to be less than $500. However, it can be equal to $500, so we can do the equal to as well. Okay. So now we've got 35 cents per carton of milk and $75. Well, the delivery charge of $75 isn't going to change based on the number of cartons. That's always going to be the same. That's our constant. Okay, so we know we have to pay $75 no matter what. Then we're going to add to that the cost of the milk. Well, it's 35 cents per carton, so I know 35 cents each for each carton. So I would add as many cartons, right, as we were going to do. But I don't want to write it out that way because I'm not sure. So for that repeated addition, I just use multiplication, and we use a variable because we're not sure how many cartons we need. So there's our inequality. Okay, now I'm going to subtract 75 from both sides to solve this inequality. That becomes 0, so we're left with 0.35m is less than or equal to 425. Then we get out our calculator because we're going to divide by 0.35, and we end up with this. And that gives us about 1,214.2857. Okay, which we can't really have that decimal, so we can just say 1214, right? It's greater than or equal to m. So that means we can have 1,214 milk cartons we can purchase or less. Okay, that's kind of the B part. I'm not going to write out the words, but you can just listen. So again, we can't have more than 1,214. Okay, so every quantity from 0 to that, because you can't have a negative amount of milk cartons, okay, is what we're looking at. So now when it talks about, so with interval notation and set notation, okay, with interval notation we use brackets and numbers it can include. We can order 0 up to 1,214. Okay, so that's kind of like the starting number and the ending number. Now set notation uses kind of these weird ones, and for these values of x, we would say, generally because we use x, but we could use a m, we would say 1214 is greater than or equal to m, which is greater than or equal to 0. Okay, something kind of like that for the set notation. But I'm not too concerned with the part C. We're looking more at creating the inequality and solving it. All right, let's take a look at the second question. Okay, students love to put ranch dressing on everything, so Elvira needs to keep plenty in stock. The students eat about 2.25 gallons of ranch each day. Elvira started the school year with 130 gallons of ranch dressing. She needs to have at least 20 gallons left when she reorders to have enough in stock until the new order comes. For how many days will the ranch dressing supply last before she needs to reorder? Okay, so again, what do we have? Well, we know we're eating 2.25 gallons of ranch each day. Okay, so the number of gallons of ranch eaten is going to change. Okay, that's going to be our variable, right? Elvira started the school year with 130 gallons of ranch dressing. That won't change. Well, I mean, it'll go down, but we won't. How do I want to say that? That's where we're starting, I guess. Okay. We know that we can't have less than 20 gallons. Okay. So, we would start with the 20 and say our number has to be greater than or equal to 20. Okay, it can't be less than 20. So, we started with 130 gallons, and we're eating, well, the students are 2.2 gallons per day. So that's what my inequality is going to look like. Okay, so to solve it, I subtract by 130, giving me negative 110. It's less than or equal to negative 2.25d. Divide by negative 2.25. And because we're dividing by a negative with inequalities, that flips the inequality. We end up with d and then negative 110 divided by 2.25 gives us about 48.8 repeated. Okay, which, if we think about it, it's in days. So what we're saying in words, okay, part B is really that we've got, 49 days basically. They'll run out, or at least drop below that 20 gallons on the 49th day, but barely. So you could say 48, you could say 49. That's how many days till she's going to need to reorder. Okay, so again, if we were to do interval notation, we'd start at 0 because negative days don't make sense. And we'd go till 48, we'd say, because she wants to probably order on the 48th day. That set notation for our D, we went from 0 is less than or equal to D is less than or equal to 48. Okay? There's 2. All right, let's take a look at the next one. The prices on many of the cafeteria foods change during the year. Elvira finds that she has ordered veggie burgers 4 times and paid $78, $72, $87, and $90 on the orders. To stay within her budget, Elvira needs to be sure that the average order of veggie burgers is not more than $82. How much can she spend on the 5th order to keep the average order within her budget? Okay, so these values are how much she's had to pay, correct? So we need to make sure that she doesn't go over 82. Right, so $82, okay, our number has to be smaller than or equal to that, okay. Now remember, to find averages, we just add everything up and divide by how many there are. Problem is we only have 4, and we're going to have to order a 5th time, so let's pull F for the 5th order. So we would average that out and have it over 5. Now we can probably simplify this a bit, right? We know that 78 plus 72 plus 87 plus 90 equals 327. So I'd probably want to write 82 is greater than or equal to 327 plus F over 5. So there's our inequality. So to solve, we times both sides by 5. So 82 times 5 is 410. Greater than or equal to 327 plus F. Subtract 327. I get 410 minus 327, and that gives me 83 is greater than or equal to F. Okay. So we have to spend less than $83 or equal to. So be what words the quantities would work. So any number less than 83, probably between 0 and 83, because it doesn't make sense to have a negative. Again, interval notation would look like 0 to 83. Set notation for F, 0 is less than or equal to F is less than or equal to 83. Okay? All right, number 4. Elvira can purchase ready-made pizzas for $14.50 each. If she makes them in the cafeteria, she can spend $44.20 on the ingredients and $6.25 per pizza on labor. For how many pizzas is it cheaper for the cafeteria to make the pizzas themselves rather than buy them ready-made? Okay, this one's a little different, right? So if we look at this, $14.50, that's per pizza, okay? And $6.25 per pizza on labor, with $44.20 being the constant. So if she ordered them, it's just $14.50 per pizza, okay? And we want to know, when is that more, okay, than making them themselves? With making them, we would pay the $44.20 first, then we would add $6.25 per pizza, okay? So here's my inequality. So what I need to do is to subtract $6.25. Okay, so 14.5 minus 6.25 should be 8.25. So greater than 44.2 divided by 8.25. And we end up with 44.2 divided by 8.25, which is P would be greater than 5.35. Okay, so when you make essentially more than 5 pizzas, that's when it's cheaper to do it in the cafeteria. So that's kind of part B. So making more than 5.35 pizzas is what will be cheaper for the cafeteria. So interval notation, that would go from 5.35, or just, we'd probably just say 6, round that up, to infinity, right? Because it's never going to end, according to this. So set notation for P, okay, infinity is greater than or equal to P, which is greater than 5.35. All right, number 5. Elvira is comparing prices between 2 different suppliers of fresh lettuce. Val's Veggies charges $2.50 for delivery plus $1.50 per bag of lettuce. Sally's Salads charges $100 for delivery plus $4 per bag of lettuce. How many bags of lettuce must be purchased for Val's Veggies to be the cheaper option? So that's going to be kind of like number 4. So we're essentially creating one on each side. So Val's Veggies would be $2.50 for delivery plus the $1.50 per bag of lettuce. We'll call that L. Okay. We want Val's to be the cheaper option, so that's going to be less than Sally's, which would be $100 for delivery plus 4 times each bag of lettuce. So there's my inequality. So I can subtract 1.5 from both sides. So I get 4 minus 1.5, which is what, 2.5? Okay, so I have $2.50 is less than 100 plus 2.5 L. Subtract 100. We get $1.50 is less than 2.5 L. Divide by 2.5. And I get $1.50 divided by 2.5. And we get 60. So 60 is less than L. So basically we have to order more than 60 bags of lettuce. Okay, so B, ordering more than 60 bags of lettuce would give us our answer. Okay, interval notation would be from 60, because it's going bigger, to infinity again. Set notation would be for L, 60 is less than or equal to L, is less than, I guess I can just probably leave it like that, can't I? I don't need to put the other side. Okay? Alright, now the last one here. Each student that buys school lunch pays $2.75. The cafeteria typically brings in between $11.68.75 and $14.38.25. How many students does the cafeteria usually serve? Okay. So if I'm thinking about this, it's $2.75 per student, right? And we bring in between $14.38 38.25 or 1168.75. Okay, so if we think about this, that's the low end of things. That's the high end of things. So we're kind of in between, right? So this 275, if we divide it on both of those, that should give us our number, right? So 1168.75 divided by 2.75 gives us, and that could be equal to as well, 425 is less than or equal to S is less than or equal to 1438.25 divided by 2.75. It's 523. Okay, so in words, between 425 and 523 students. Okay, set notation, just go like this. Interval notation, 425 to 523. All right, there we go.